So once you've started writing some code, you might notice that it can get out of hand. You might have several lines of code and might start to get messy. Sometimes we make lines of code that could be converted into like a block of code or a function that might be more easy to call. It makes the program that you're writing a little bit more modular. It makes it a little easier to read. Another great thing about that is that it makes, if you write a function that you like, you can take that and reuse it in another program that you're writing. So those are two advantages of learning to write functions and incorporating that into your workflow. So when we write our own functions, there are three parts to this. First is the return type. You'll usually see void, int, float, string, or some other data type. With the exception of void, these are int, float, string. These are data types that we would want to get returned from that function. The function name, you need to have a name, and you should try to choose a name that makes it kind of clear what that function does. And you may or may not have arguments or values that are passed into a function. And these values can be used in the function to either do a calculation, or generate a value, or draw something. You'll see that when we write the function, the parameter, we sometimes call these things parameters. They're the variable declarations inside the function definition. Let's take a look at what that means. Here you can see is the general structure of it. We have the return type, which is the very first part of it. You have function name, and inside of your parentheses, you'll have parameters, or this gives you an indication of what values can be passed into the function. And there may be no parameters, or there may be a bunch that you can separate with commas. And inside these curly braces, you'll execute the code from there. Okay, so let's use that template, and let's take a look at one type of function. This is a function. It's called the return type is int, so it's going to return an integer. The name of the function is times 10. So I'm trying to choose a name that makes it clear what that function does. And inside the parameters, it takes one integer, and we're going to call it n. And the name of the variable in here that you declare is not super important. And we'll look at an example in a little bit. But inside of the curly braces, you'll see we perform this calculation, n equals n times 10. So we pass that number n, that integer n, into this function. We take that number then and we multiply by 10, and then we return the n. When you have a return type like this, int, float, string, you always have to return something. So hence the idea of a return type. So here is that code written into processing. I just want to go over this. I've created just a void setup. I only want this to run once. At the bottom, I've written the function. Return type is int. The function name is times 10. The parameter here we're setting is int n. And we're doing this calculation again, and we're returning n. The way that this works is I'm printing this to the console down here. So the way I call it is I write the function name times 10, and I pass that number into it. In this case, it's going to be 4. So if I run this, I should take 4, multiply it by 10, and return that number down here as 40. Okay, I want to try something else up here. I'm going to make an integer n here. I wanted to show one thing about passing these arguments into functions. So I have this integer n equals 3. This is a global variable, and you would think that it would get passed down into here, but this you can kind of think of as this has its own scope, its local scope, and so this n here, whatever gets passed into here, is going to overwrite this. So this 3, when if I run this sketch again, it's not going to put 3 inside of it. It should still be 40. It's still passing the number up here that we passed into it 4. And just so you also see something, I'm gonna put in this little snippet that I had. I want to print another line to the console, and so this just lets me put some specific type in front of it, and then I'm just adding what I'm gonna put in the value of n. So this number, this n3 should come into here. So all of this is to say that even though we're returning n here, the value of n does not get changed up here. This n remains 3, and you can see it says n equals 3 when I run it. You can sort of think of it like that this is a sort of different instance of it. Again, because of the scope of this, it remains separate from this value up here. So that's important to keep in mind as well. Let's take a look at void. Again, what does void mean? You've probably seen this already. We have void setup and void draw. Those things basically mean that nothing gets returned. There's no value that gets returned, but we can run code within that block. So we don't need to write return like we did in the previous example. Let's take a look at what this might look, something like this might look like. Here we have, again, the return type. In this case, it's void. The function name is 2circles, and this is going to take 3 values, the 3 parameters, x, a y, sizer, things that we've kind of been using before, and it's going to draw 2 circles here. You'll see the ellipse function that's being called, x, y, sizer, sizer, and then 1 circle that's shifted over, x plus sizer. And I should also say that we've been using functions already, pre-built functions such as ellipse. It kind of works in the same way. Processing includes a function called ellipse, and what we're doing when we call that function is we write the name of the function and we pass in these values or these arguments, and then when processing handles it, it takes those values, kind of like this function here, this void 2circles, and it kind of does what's inside the curly braces, and it draws that thing. So here's an example of what that looks like.
We have a void setup here, void draw, and when you create your functions, a good place to put them is probably after void draw, and you can see I've set that up here. Return type is void, so it doesn't return a data type. The name is 2circles, and then we have 3 parameters here that we're defining, x, y, and sizer. Again, when you and you can see when in draw, when you call the function, you call the function name, and you need to have the same number and type of values or arguments passed into here. So this is going to be an integer, and so is this, and this 10 is an integer. Now, if you did something like 10.5, you're going to have an issue because that 10.5 is a float, so be mindful of that. And here we're just drawing 2 circles right next to each other, so it's pretty basic, but what does that look like? You can see 2 circles. This is just to show how to write a function.
So using this information or this knowledge, let's go ahead and reorganize some of the code that we've been using. Another name for this is called refactoring. I think coding can be a really iterative process where you're coding things and figuring something out, but then you're reorganizing it and making it simpler, making it more modular, making it more reusable, and also hopefully you're adding comments and things. So it is an iterative process.
So let's take our bouncing ball example that we've written in the past, and let's rewrite this to use functions instead. There are a few main components of this, and maybe just conceptually thinking about this will be helpful. One is sort of just moving it from, moving it vertically. So most of that happens in this line of code, just adjusting the Y position. There's also that bounce that happens at the end, which you can kind of see here. If one of the 2 conditions is true, we've got to change the direction of it. And you could even say that drawing it to the screen is its own separate function. So let's go ahead and start to reorganize, refactor this code. As I said, there is probably a run function, or maybe I'll call it move. Void bounce function, and void, maybe we'll call it void display. So let me start to move these things around. I said that y plus equals speed would probably go well and move. This block, this if statement, will probably go well in the bounce. I'm just creating the functions yet. I haven't called them yet, which we'll do inside of draw. And then for displaying it, it's pretty much this right here. And now I've moved all these things around. Let me just format it. Okay, so I've got void move, void bounce, void display. And inside of my draw, why don't I just call these functions move, parentheses, semicolon. And I want these to happen in a certain order. I want to move it. And then I want to run the bounce and check if, hey, is this the right situation? And let's just go to display. So let's see if that works. You won't notice any difference from the way the program is running, but we've rewritten it, refactored it using functions just to play around with maybe sending an argument or putting a parameter in here. Let's say I wanted to change the position here. If I want this to accept parameters, I can declare it here. So that this now takes 1. And maybe let me put X down here. Again, even though, actually I haven't, that's okay. I haven't declared that variable, which is fine because again, this is kind of self-contained. So I'm going to take, I want to, when I call it, now I'm going to have an issue if I try to run it right now because I've created that function to take one parameter and I haven't given it a parameter. Or when it's up here, it's called an argument, and when it's down here, it's a parameter. It's a little confusing, but I need to give it a value. So if I say width divided by 2, I don't need to declare the type up here, but it does need to match in type and number to this thing down here. So it needs to be an integer. So again, I can't put a float in here. So this is also going to do the same thing, but what's great about this later is I can put different numbers in here. Now I want that to be width divided by 4. I could even go super crazy. Again, I can't throw a float in there, so I'm going to convert it into an integer. I could do something crazy like this. Whoops, I think I need one more. Now it's just going to be a random, it's randomly picking the X value and shooting it around. So hopefully you're kind of seeing the value of doing this. It does get cleaner later, and it's modular, so I could take this code to another sketch and use it. Now that we've gone over some of these concepts, a good assignment to practice on is writing our own functions, calling them within draw, and we'll make 2 separate use cases. One will be a pattern sketch, and we'll create functions to generate specific forms, and then we'll take those same forms, those functions, and use them in a drawing sketch. So this should highlight how modular and flexible using this kind of organization is. So let's start just with a sketch. We're going to start with the pattern sketch first. So I'm just kind of putting the basic structure in. Let's look at maybe the size that we want to set it to. I'm going to make it a little bit wider, 1000 by 600. And I'm going to change the frame rate to 1 because this is a pattern sketch and I just want to see what that pattern looks like if it iterates like once a second, because I'm going to use some randomness here. Okay, background, we'll use a grayish background, so 200. Let's also set a stroke. I'm going to create some shapes here that I want to be outlined. This is going to be kind of a yellowish stroke. Now to do a pattern again, we're going to use nested for loops. So we're going to use for. The 3 parts of this are declaring and initializing a variable, I in this case. We'll say while I is less than or equal to width, so it goes all the way to the edge of the screen. I plus equals sizer. We're going to use sizer again. It's just a variable that I like to use. I realize I haven't made sizer yet, so I'm going to go up to the top and put that as a global variable up here. sizer is equal to 50. And that's going to work well because it divides evenly into the size here. If it didn't, you might have some issues with creating floats or something when you divide them. Let's see, but actually, sorry, not in this case, but I just want to be aware of that. It would just divide a little bit unevenly probably. Let's see. Int j equals 0, j is less than or equal to, this is the vertical part, so we'll say height, and then j plus equals sizer. So it's going to be a pretty regularly spaced pattern, maybe not regularly patterned. Okay, from here we're going to use a technique that we've used before. We're going to create a random variable r, and we just wanted to switch in between two different options. But actually, let me comment this out for right now because I just want to start with creating my own function. The thing that I want to make is kind of like a bullseye pattern. So I am gonna just write bullseye here, and then I'm going to call it, and I'm going to call it with some arguments. But I now also need to create that function down here. So I'll write bullseye. Like I said, I'm going to go back in and flesh it out. But basically what I want to happen, I'm just trying to think about it. I want to shoot in or send over pass x and y value, probably maybe one value for how big it is, and maybe one more variable that might be how many rings this has. Like if you think about bullseye, it's usually concentric circles here. So those are things that I'm starting to think about. Now, I could use ints here if I was assured that I was always going to use ints. Earlier I was talking about making sure that, I guess, if you're making a pattern that it's easily divisible, to be a little bit more flexible, I'm going to use a float, because you can pass a float, you can pass an int into something that asks for a float, but you can't do it the other way around because the decimal will mess it up. So I'm going to just for flexibility, say float x and float y in case I want to use this later, and I want that flexibility. Let's see. So for the sizer, I guess in this case, I'm just gonna say float s. This is kind of like the size of the circle, as I said. I also, I was thinking, in addition to the number of repeats I want to kind of specify how much space is in between each circle. So I'm going to make a new variable here called increment. So that's the increment in between that, and repeat is the number of repeats, let's say. I think that will be okay for me. Okay, it's already telling me I'm not using these values, so let me use those in here. If I want to do a series of circles inside of each other, actually I could use another loop. I'm going to do another loop here. I is equal to 0, and again, the reason I like for loops is I can reuse these variables, and because of local scope, they only apply to the specific code block, so I don't need to worry about confusion there. I is less than or equal to the repeat. That's the number of times it's going to repeat, and I plus plus is just add 1 to I. Okay, so we're setting this up, and we have ellipse. The center point will be x and y, and now we're using size here. So what I want is the first time this goes through the loop, it's the biggest circle. The next time it's the second biggest, third biggest, so on and so forth. So maybe what I will do is, in this case, I already know ahead of time kind of what I'm making, but let me try taking s, and I'll say minus I times increment. So that means that the first time it goes through, it's the full value of s, and then it's the next time it does 1, it subtracts 1 unit of the increment, and then the second time it does 2, or I should say the third time, because this is going through and going 0, 1, 2, 3, up to the number of repeats that I'm going to do. Increment, and let's do this, I guess, just for right now. Circle is just the same amount, so yeah, that's. And we're gonna tweak this. I just want to simplify this. That's kind of what I'm thinking. Okay, so now we need to call it, and we also need to make sure that as far as the arguments and parameters go, so arguments we said are the things that get passed up in here, and then these are the parameters that we declare. They must match in number and type. Okay, so I have to make sure I put 1, 2, 3, 4, and I actually have 5 different arguments in here, and they should match up in the same type. So I gotta put floats in here, and then the last one I gotta make sure it's an int. I can't put 5.5. Like I said, I could actually throw in an int where a float is, and it will kind of auto convert it, but just keep that in mind when we're going. So I actually just want to, when I'm looking at this, because if I'm looking at the code, it's shifting over 1 unit of the sizer, which is kind of like my base unit of the grid. I think I could just do I and j. For the sizer, maybe I'll do, maybe I'll just say sizer here. And the next one is, what's the increment in between them? Let me see what 5 looks like, and the number of times I want the circle. The number of repeats is 10. Let's see what that looks like. And okay, so you can kind of see. Actually, I should maybe I need to put a fill on these just so we can see something. I mean, it looks like it's a yellow stroke, as I said, but I couldn't see the contrast. So let's see, let's run it. There you go. So you can see that these are 10 circles that are inside of each other. Yeah, and that actually looks okay to me. So okay, so that's one example of me creating a function. I want to make another function here that is sort of a similar type of form. It's like a bullseye, but with triangles. So it's like nested triangles. So I'm going to make this function and call it triangle repeat. Let's do a similar thing. It needs a starting point, float x, float y. We'll use s again for like the size, float offset again, and we'll do int repeat. So because it's similar, we can set it up in a similar way. I'm gonna need to use this same code, and I can just copy and paste this because I know what it does. Make sure you open and close these curly braces. Again, if you miss one of these, your code will break. Okay, so from here, let's I'll put a black fill for right now. Let me hit Command T to just clean up the code, and then let me just write how this code's going to work. So the triangle function, there is a pre-written one in processing. It takes basically the vertex points of the three points that make up the triangle. So if we want to start from the center, we'll use x. That's like the center point. As far as the y value goes, we need this to the center of the triangle. If we're thinking about a sort of symmetrical triangle, is going to it needs to move upwards. So we actually need to subtract s, or the sizer, and we'll do a similar thing that we did here, plus s increment. Oh, you know what I realized? I mean, I think it's fine to say this. In one I put offset, in the other one I put increment, and it's fine. You can name these how you want to, because these are self-contained. But I just want you to be aware. It's basically doing the same thing as this. So minus I times, in this case, offset. I hope that's not too confusing. but we'll keep going from there. And then x, this is the bottom left corner. It's going to be minus s, or that size. And then we'll do plus I times offset, so that kind of pushes it inwards or closer to the center each time it iterates. And then y plus, now we're going to do plus s because that's pushing it downwards, and again we're the positive y value is moving downwards, plus, and then, but now we want it to come back up each time it runs, so we're going to do minus I times offset. It's a little bit of a kind of mind mind trip to kind of think about this, but another way to think, once you kind of have these values, you can also just do it piece by piece and think, now we're moving on to the bottom right hand corner, so it's going to be x plus s, and then now it's going in the out, we want to come back inwards, so we're going to do minus I times offset. And then we'll do the same y value here because they're at the same height. So you could copy and paste it. And honestly, yeah, this might trip you up. You can take a look at the code sample to look at it more closely. If you can't see that, I know it's, and also my screen I'm sort of running out of real estate here. So that's that code. This is called triangle repeat, and I hope I did that correctly. So let's go back into here, and we're gonna set up this random situation. If r is less than 1, so we're saying this is going to be about 50% of the time, we'll run that code. Otherwise, we're using a conditional here. If that statement is not true, then let's run our own function that we wrote, triangle repeat. We need values to throw into it, I, j, sizer. Let's see, we could do 5 again. I don't think that 10 of those will fit in there. I think might be closer to 5, so I'm gonna change that. And hopefully everything is all set up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. The numbers, the arguments and parameters match. So let's give that a whirl. Ooh, something really interesting happened. It looks like I just wrote some things off here. Oh, here we go. Plus I times offset. Okay, so hopefully you caught that. It was multiplying by s, and it was just going really far down. There we go. So it looks like actually my triangles are a little bit big. So what I can do actually is make the sizer smaller. So maybe I'll just say sizer divided by 2. That makes the initial size a little bit smaller. Yeah, and there you go. That starts to feel more uniform. So I mean, even that now you can maybe see the power of writing functions and being able to change the parameters or the arguments that you're passing, and it really quickly updates. Let's have a little bit of fun with the fill. What I want to do is show you a map function, which is a nice way of remapping values. If I wanted to, let's say, use X, for example, to try to drive the color, one problem is that X in this case is going to go all the way up to 1,000, and it doesn't really map well here. So at a certain point, it hits, I think it hits white or something, right? So you no longer see it, and yeah, you see the yellow lines there. But what I could do is map that value, or maybe what I'll do is, what if I wanted to use I to color this? You'll see that because it only goes from 0 to 10, it's a very small amount, and it's probably going to be black, and you won't really notice the difference. Kind of like what we had before. But what I could do here is map the value. The map function takes 5 values. One is, what's the first value that we want to remap. The other one is the The next one is the minimum value that it could take. The next is the max value. In this case, I believe it's 10. And then the other one is what's the new minimum value and the new max value. So, and I also want to close that parentheses there because this needs to fit all the way inside of that fill. Okay, so now what this is going to do is remap I, so that instead of going from just 0 to 10, it's going to go from 0 to 255, and you should see kind of a gradient across this. This is only the circles, the bullseyes. So if you look at, and I should say that this is happening inside of the circles themselves. You can see it gets dark at the outer edge, and it gets a little bit lighter in the middle. One other thing that I'm noticing is that the quality of the image is kind of low, so I'm going to do pixel density 2 up here to make it a little bit nicer. And I'm just going to keep playing with this to kind of help me draw colors. This is just grayscale that I was doing, but I'm actually going to go in and the other thing that's nice about the remapping is that you can actually make them go in the opposite direction. Or I should say, these are, instead of minimum maximum, you could think of them as the endpoints of the scale. So in this case, it's going to go in the opposite direction. I have some values that I'm going to plop into here, but hopefully you understand what I mean when I use the map function. So I'm going to do that as one. Sorry, I'm going to do that as one value. That's the red value, and then I'll do 200. Then I'll do map I 0 repeat 0 to 255. So this is going in the opposite direction, and we'll just take a look at what that looks like. Yeah, there we go. So we're seeing that we're creating a gradient, and because we're sort of moving the values across the red values and the blue values, you're getting this kind of nice gradient. So I'm going to just take that fill, and yeah, why not? I'm just going to place it into the other one. Keep it easy. There you go. So yeah, this is my pattern sketch, and now I'm going to take these things and make a drawing tool sketch out of them. So we can do this pretty quickly. Again, I'm going to just set this up. Here are my functions all ready to go, and I'm going to put them inside of here. I'm also going to, I need this global variable up here because it gets referenced in the other sketches or in the other functions. I'm going to just grab these two lines, size and the pixel density. I actually want the frame rate to be a little bit faster so I can actually draw. Let's take the background from here and the stroke, and now we can kind of set up a key press. We'll do if key pressed, and we've used this in the drawing tool sketches, if key press, and let's set up two key presses here. One will be maybe C for circles and bullseyes, and T maybe for triangles. So if, and we need to make sure that we're using double equal signs, single quote, if the key equals, well, let me do C first. Then we will run our bullseye sketch, or bullseye function. Instead of I and J now, I'm going to put in mouse X and mouse Y so that it's going to follow my mouse. And then the next thing I'm going to do is just say, if I press T, then let's run our triangle repeat sketch, which is down here, or function, sorry, keep phrasing it improperly. In the last previous sketch, we found out that we have to use a smaller sizer size, and that's because it's the triangle is like is offsetting itself on both sides. So I think this will let us start running it at this point. And you can see, okay, oh, there we go. Let me turn off this background actually, because I want to kind of draw with it. There we go. This is me pressing C, and then this is me pressing T. Oh, there's something funky going on here. Oh, the reason is that I actually have too many repeats, and so it's actually going negative, and it's drawing those shapes in the wrong direction. So sorry about that. That's why I chose to only do 5 repeats for that. And then here's T. Yeah. So this is my drawing tool. And again, once I wrote these functions, it's really modular, it's really reusable. I can pull these out and use them in another sketch. So this is a good assignment to work on to understand these concepts.